This video is a review of atomic structure. This stuff is so important. I want to make sure that you've got it down cold. So first of all, I want you to just get the big picture of an atom. First of all, there's a nucleus, and inside that tiny nucleus, it has all the protons and all the neutrons. They're all in the nucleus. So the nucleus has a positive charge, and all the mass, just about all the mass of an atom is in that nucleus. And outside the nucleus, somewhere, are electrons, and we call it an electron cloud. Has a negative charge, and just about all the volume of the atom is in that electron cloud. And the electrons make up the electron cloud. Now, there's really no fence that's keeping, or a membrane like in a cell, that's keeping those electrons in the atom. What's keeping them together, these electrons together with the nucleus, is the fact that opposites attract. The nucleus is positive, the electrons are negative. That is a key point in chemistry, that opposites attract. So the electrons are negative, the nucleus is positive due to the protons, and that's just a key point in chemistry. Opposites attract. Those negative electrons are attracted to the positive nucleus, and that positive nucleus is positive because of the protons. All right, now the other key point is that like charges repel. So all that positive charge that's in the nucleus, all those protons, like charges repel each other. It's kind of like trying to put a north and a north magnet together, because you can feel them repelling and pushing apart. And so there comes a point in a nucleus where the nucleus is unstable from those like charges in that nucleus repelling one another. All right, so that's the big picture. So now let's kind of start looking at the details. Let's talk a little more in detail about the proton. The proton does have a mass, and in atomic mass units, we say that the proton is 1 AMU. Has a positive charge, and the number of protons is the atomic number, always. The atomic number on the periodic table, on most periodic tables, is right above the symbol. So here we have Fe, that's iron, atomic number 26. Iron has 26 protons. The atomic number is always equal to the number of protons. Here we have potassium. Atomic number 19, 19 protons. Always. That will never change. If it is potassium, it has 19 protons. The atomic number of sodium, Na, is 11. So the number of protons in the nucleus of sodium is 11. Always. The atomic number is the number of protons. Got it? Very important point. Okay, so those protons have mass, but so do the neutrons. Now, we really haven't talked much about them. The neutrons are also in the nucleus with the protons. They have no charge, but they do have a mass. And the mass is about the same as a proton, and in AMUs, we're going to say it's 1 AMU. This brings up another really important number. This is called the mass number. It is the number of protons, the atomic number, remember, plus the number of neutrons. The two things in that atom that have mass are protons and neutrons. And when you add them together, you get the mass number. The mass number is not on the periodic table. It is not on the periodic table. The way we represent a mass number, we do it in two different ways. We'll have a superscript before the symbol of an element. So here's a 3 with hydrogen. That's the mass number, 3. The protons and neutrons added up together is equal to 3. Or another way that we can represent it is the symbol, dash, and then the mass number. So 3 is the mass number for this form of hydrogen. Now, hydrogen's atomic number is 1, and sometimes put the 1 there. But they don't have to put that atomic number there, because if it's hydrogen, its atomic number is 1. Here, they never put an atomic number in. It's just the way to represent a mass number. Here we have 32 as a superscript with phosphorus. Another way to write it is P-32. Again, this 32 is the mass number. And the mass number is the number of the protons and the number of the neutrons. So let's go ahead and use this and try and figure out how many protons and how many neutrons are in that hydrogen and in that phosphorus. So here we go. Here is our periodic table for hydrogen. Atomic number 1, so therefore it must have how many protons? Right, it has 1. Whatever the atomic number is, that's the number of protons. Now the mass number we said was 3. Okay, it's written here and it's written there. This is the number of protons plus the number of neutrons. The way you get the number of neutrons is to take the mass number, 3, and subtract from it the atomic number. This is protons plus neutrons. This is just protons. When you take the difference, you get the number of neutrons, which is 2. Neutrons is 2. Let's try it for P32. All right, here's the periodic table. Sometimes we forget there's information on there, and you always have the periodic table in front of you. Atomic number 15, that means the number of protons is 15. They didn't put the atomic number here, but they could have. Okay, P32, mass number is 32. Protons plus neutrons is 32, minus the 15 protons, and what we're left with is 17, and that is our number of neutrons. A good way to check is add your neutrons and add your protons together, and it should equal the mass number. Did it work over here? Neutrons plus protons, did it equal the mass number? It did. And you can get pretty big numbers with this. Here we go, iodine 125. Mass number is 125. They could have written it like this. Go to your periodic table, there's iodine, atomic number 53. So therefore the number of protons is 53. To get our number of neutrons, we need to take our mass number, subtract from it the atomic number, and what we come up with is our number of neutrons, which is 72. Let's check and make sure we're right. Neutrons plus protons, does it equal the mass number? It does. Great. All right, protons plus neutrons equals your mass number. If you have a mass number, subtract from it the number of protons, which is also the atomic number, and you're going to be left with neutrons. Okay, well, let's move on to charge now. We're not going to talk about mass anymore. We're going to talk about the charge on an atom. And the two subatomic particles that have charge are the protons and the electrons. The protons are positive, the electrons are negative. An atom has no charge, 0, none. We say they're neutral. So in other words, the positives and the negatives are the same. So our number of protons, the positive particle, equals the number of electrons, our negative particle, for an atom. So if we look down here, we got a big old S there, and there's nothing here. There's not a 0, there's nothing here. What that means is there's no charge. So this sulfur has no charge. Well, let's go to our periodic table here. The atomic number is 16. This sulfur atom has 16 protons. Because there's no charge, the number of electrons equals the number of protons. The positives and the negatives have to be the same. And so we have 16 electrons. All right, let's move on to magnesium. All right, if we look at our magnesium, there's nothing up here. There is nothing up here. So that means it has no charge. So the number of protons must equal the number of electrons. Well, it's atomic number 12, so that tells us that we have 12 protons. Because there's no charge, the number of negative particles has to be the same. So we also have 12 electrons. Now, I want you to continue watching the next video because we're going to look at what happens when we get charges on these atoms, and we call them ions. So we're going to be looking at that in the next video. So go on to the next video entitled Ions, and you'll see what we do when we have a charge.